Video lesson 14.4, equations of a circle. So we've touched base on this already, but we're going to go in a lot more detail today in this video with the equation of a circle and what we can use with it and how we can interpret the information and everything like that. So first things first, the equation of a circle, as we have up here. All right, here's your equation of the circle formula. It's important to be able to identify and know that the we'll do a different color here, that the H here and the K, right, that will ultimately represent the center of your circle. All right, you have to be careful with how you extract that, but that's what comes out of it. And then last but not least, the R term is your radius of your circle, and in the formula, that's squared. So the formula that we have here, very useful, very functional to be able to use. But when you have it in this form, you can right away be able to extract what we have is the center and the radius. This is specifically called center radius form. So it's center radius form, right? If you have which we'll see later on in another video. They could give it to us in a general form, and then we would be able to manipulate it into this form. This is the most functional and useful form of a circle, generally speaking, because we can get so much information out of it just by the equation itself from there. So like I said, so here you've got your center of your circle here, which is h comma k, which again is a relationship of what's happening to the x and y terms being squared. X and y are specifically the point, any point on the edge of the circle. So in this case, it represents any possible point that can be done there. And then again, as we already said before, we've got r, which is our radius. And I'll just do it here in yellow. That's what we got there. And we all know the radius is from the center of the circle out to the edge of the circle. All right. So first things first, extracting this if it's given to us. If it's given to you in the form of a graph, generally speaking, it's very straightforward and pretty simplistic. From there. But again, they could always kind of give you some things that make it a tad bit more crazy. But we have our center point, which we are indicating here as -4, right? -4, 2. Right. So again, if I use my formula here, x minus h squared plus y minus k squared equals r squared. So if h and k are -4 and 2 respectively, I can simply plug those in. So x minus the h, which I'm going to call -4, and we've got plus y minus the k value, which in this case is 2. And that's going to be equal to the radius squared. So the radius we have to find. So if it's given to me in a graph, I want to find a point that's on the edge of the circle that's nice. If I was to pick something like here, that's a hard point to know what exactly that is. So we don't want to go with something there. We would rather go something like here. So I would pick points like here, here, right? Right, something like that. Actually, that one's off a little bit. That's just my picture, though, my mistake. But when you have it, you want to pick a nice point, something that's a nice, easy point to calculate. Now, it may not be horizontal or perpendicular with it. That's fine. It could all be like something out here. But again, I want something nice that I know for a fact crosses at one of the grid points perfectly. All right, so I'm going to stick with this one over here. So that would be my radius, right? So my radius here in this case, I don't have to calculate it because I'm just using, in this case, a horizontal line from the center. So I can just count the boxes, 1, 2, 3. So my radius is 3. So that's 3, and that's going to be squared. Now, if they didn't give it to you, like let's just say I had to use like the point over here, right, to find my radius, which ultimately would be the same thing, but I can't just count the boxes. I would then have to use a distance formula to find that value if necessary, okay? But luckily, we don't have to do that here, so I'm just going to erase that so you don't have to think about it. All right, once I have this formula, it's just about simplifying it. Main thing here is minus a negative, right? That becomes plus. So this becomes x plus 4 squared plus y minus 2 squared, all equals and then I square the 3, and that gives me 9. So this is the equation of our circle in center radius form, and that's how we are going to come up with the equations utilizing the center and the radius. Notice, again, when you do this, the 4 and the -2 represent the center, but it's minus an h and minus a k. So basically, think about it as opposite. When it's in this simplified form, right, we basically take this as an opposite. So opposite what this is would be my x portion of the coordinate, and opposite what this is our y portion, because it's minus the h and minus the k. So which is what happened when we simplified it. And then obviously the radius, we just take the square root of it, and that would give us what the actual length of the radius is. All right, let's get through some of these practice questions, and then they'll kind of make sense as we go through for some of these. So this first one here, again, they're just giving us the center and the radius. We're just going to plug them in and go from there. So pretty straightforward. Here's my h, here's my k. So we've got x minus -3 all squared plus y minus 8 squared equals 4 squared. Simplify this, I get x plus 3 squared plus y minus 8 squared equals 16. And we're good to go. Not too bad. Over here, right, same thing. Here's my h, here's my k, this is my r. So we've got x minus 0 squared plus y minus -3 all squared is equal to 4 squared again. So again, because it's a minus 0, I can just simplify this to just x squared. Nice and simple. Here I can make this y plus 3 squared. Again, make sure it's in parentheses, equals 16. And there's my equation for the second one. All right, for the third, again, 0, 0 means that my h and my k, again, they represent the change from the, what that h and k represent is the change from the origin to where the point actually landed, where the center of the circle is. So there is no change. There's no horizontal change. There's no vertical change. It's at 0, 0. So I don't even have to really go much here. X squared plus y squared, right? There's nothing happening. So there's no minusing anything here. So that's just going to be equal to 3 squared, which is 9. So really a nice, easy one to be able to utilize when there's no change like that. As we know, we don't always have to have nice, perfect lengths for the radius. So in an example like this, doesn't change here. So x minus 3 squared plus, it's going to be y minus -1, which is going to be plus. And now we have the square root of 5, and we're squaring that. Again, whenever you square a square root, they cancel out. So I'm going to have x minus 3 squared. Oh, I'm sorry, this should have been a minus -1, right? Which will become that, y plus 1. And the square root and the squared cancel, and I guess left with 5 here for that. All right. Now, the one thing you got to be extra careful with, and I find that students make this mistake, especially if you're rushing. If I take this term here and I square it, so 2 rad 6 squared, right? These are each term individually. So think about it. If I was to do this, it would be this times this, right? I have to multiply the ones in the front to get 4, and then I multiply the radicals to get radical 6 times radical 6, which is just 6. So, and this is all still being multiplied, so the answer is 24 here. So if I go to square this, right, I can't just square the radical. I got to square both parts, right? Or write it out and do it longhand, which is fine, either one. But that's what my r is, all right? That's my r value here, squared. So be careful with that. So if I was to write this one, you're going to have x minus 2 squared plus y minus a -5 is plus 5 squared. And now that whole thing equals 24. Okay. All right. Same thing over here. Again, this would be, if I squared this whole thing, right, that's going to get me 4 times 3. 2 squared is 4. Rad 3 squared is 3. So that gets me 12. So again, as a function of the equation, we have x minus a negative 1, which is plus 1 squared, plus y, no change, so just plus y squared, is equal to 12. And that's my answer. So again, with practice, they become easy to do. A lot of them can be done, mentally, or so to speak. The thing that you have to be careful of, and what I always tell my students to make sure that they do, is to write down the center, write down the radius, and then tell me what the equation is in simplest form. All right. Again, sometimes you have to extract that information out of other information, like the radius and the center and stuff like that. But once you have it, then you can go from there. All right, let's go backwards here. What if we are given the opposite, right? What if we're given the equation and we're asked to find the center or the radius? All right, we can work backwards. So again, this represents h. So this is minus h. This is minus k, right? So if it is a subtraction, it's think of it as opposite. So the center, right, is going to equal 2, 6. Because if I plug in a 2, I get minus 2. And if I plug in a positive 6, I get minus 6. Radius is going to equal whatever this term, right? This right here is r squared. So if I take that, I have to take the square root of what that is. So that gets me a 3. And there's my answers. I got a center of 2, 6 and a radius of 3. For this one here, same thing. Excuse me. I get a center that equals 2, again, opposite. Because in order for me to get a plus 3, I have to subtract a negative 3. So there's my center. Radius equals the square root of 25, which is 5. Let's do another one. Again, minus a negative 1 would get me a positive 1. So, or AKA, think opposite. So center is going to equal negative 1, 4. And the radius is going to equal the square root of 36, which is 6. All right, so in that same concept, the only thing you gotta be careful with is, again, as we've mentioned before, you don't always get a nice radius that comes out nicely, but doesn't change here. So center, we got nothing happening to x, so that's 0. This is going to be negative 2 for the y. Radius is the square root of 24, right? Not a perfect square. Do have to simplify that to go back to your simplifying radicals. That's the same thing as square root of 4 times the square root of 6, which would give me 2 rad 6 for my radius. Okay. Here, this one, no change. Radius is perfect square. This one's nice and simple. 0, 0. Center radius is 5. Hopefully that one was nice and simple and easy. And we'll do one more just because. So the center, we've got opposite of negative 3 is 3. Opposite of positive 5 is negative 5. In parentheses, don't forget your parentheses though. It is an ordered pair. Without it, it's wrong. Square root of 8. Well, that's the square root of 4 times the square root of 2. Square root of 4 is 2. So 2 rad 2 is my radius. All right. Moving on. All right. So a couple things that they could ask us to do with these types of questions. I won't do all of these because I don't want this video to go too long. But if you look at some of these, like example number 3 here, we've got pictures. We can be given the information this way. So again, if I can't calculate the radius by simply counting the boxes, if it's not parallel or horizontal to the point that we have for the center, then you have to use the distance formula, okay? Or technically speaking, if you have graph paper, you could actually calculate it using Pythagorean theorem, but again, we don't have to get into all that. We just got to worry about what that is for now. So let's go into one of these. So if I do this part here, I want to find out what this radius length is, right? Value here. So the radius is going to equal whatever this length is. So the square root of All right, again, remember, difference in the x's squared plus the difference in the y squared. So -2 minus 2 squared plus -4 minus -1 all squared. So we get -4 squared is 16 plus we've got a -4 minus a -1, so this really becomes plus. So it's -3 squared is 9. That's 16 plus 9 is 25. So we get a radius of 5. And once I have that, I can just simply write my thing, because here's my center. Right? This is my center. I have an h and a k value. So it's going to be x minus 2 squared plus y minus -1 is going to be plus 1 squared. And that whole thing is going to equal 5 squared, which is 25. Oh, I'll just write 25. 25. And there you go. There's your answer. That's the equation of your circle. All right? Not too bad. Again, same thing here on 4 and 5. Honestly, it's pretty much the same types of questions, just now they're in, instead of a graph, you're just given the information directly. So do be careful with what you have and what you need. This first one here is giving you the center point. It's giving you the center and a point on the edge of the circle. Whereas the second example gives you the diameters, endpoints. So if you found this length, that's going to be the whole way around the circle, like so, right? And we would have to then cut that in half to find just that point. So again, you just got to be careful sometimes as to what information you're given and how it kind of goes along. So from here, so doesn't really matter which one. It basically kind of do the same thing. Like I said, the number 5's got a little extra work, but the concept's the same. So let's just do number 4 here. So the radius, right, is going to equal from the center out to the edge here. So I've got the length of -2 minus 4 squared plus 1 minus 2 squared. We've got here, that's -6 squared is 36. -1 squared is 1, so square root of 37. So that's my R. Here's my h and my k, which I already know. So x minus -2 is plus 2 squared plus y minus 1 squared is now going to equal, again, this squared is just going to be 37. And we're good to go. As I said, for 5, obviously we just said to find the radius, I have to cut this in half. Or what I personally would do is I'd find the midpoint first, right? Because if this is my A and my endpoints, my thing, the center would be the midpoint. So I would actually use the midpoint formula to find that point first, because that's the center point. You need that anyway. And then use that point and either one of the endpoints to find your radius. Again, it's a personal choice at that point, whatever makes you feel comfortable. But I'm not going to worry about that because, again, this video is getting a little bit longer than I wanted it to be. So I'll let you guys kind of try that one out on your own and see how you go from there. All right. Take a chance to look through any of the other questions in the video. Make sure you understand them and then utilize the practice problems for better understanding.